SCR. So the first thing is we just need to understand how to draw the symbol first, the construction and the symbol. So G stands for gate, K stands for cathode, and A stands for the anode. And we shall have the symbol of this. So when drawing the symbol, they need to understand on how to power the gate. We shall have this as the gate. And this is the anode, this is the cathode. So this is the symbol, and this is the construction. So the construction part of it, we're talking about the construction of this diagram. It consists of 3 p-n junctions. It consists of 3 p-n junctions, and being a 4-layer semiconductor device. And it's a 4-layer semiconductor device. So we have the P1, N1, P2, N2 device. So another thing is we need to understand here is that across a gate terminal G, a gate terminal G, a gate terminal G is connected on the surface of one semiconductor layer. So you'll be asked, how do we turn on or bias this semiconductor? Then you talk of silicon. You talk of the silicon biasing. We talk of the silicon biasing. So for the meaning of biasing is that we must be able to allow current flow from anode to cathode. And for us to do that, then what is the best way that we have it? Then biasing means that we shall force the flow of electrons from the P1 terminal up to P2 and output to the cathode. Then we shall be able to talk of the issue of biasing. So that establishing a conduction path through the module is what that was, the biasing. So an SCR is biased by several methods. An SCR is biased using using two modes. Using two modes. So we shall explain that. So an SCR is biased using two modes. So mode 1, when the anode is more positive with respect to the cathode. When the anode is more positive with respect to the cathode. Junctions J1 and J3. Junctions J1 and J3 are forward biased, while J2 is reverse biased, while J2 is reverse biased. So J2 will allow leakage current. J2 will conduct leakage current. J2 will conduct leakage current. And therefore the ACR is off because one of the junction between them is not conductive. Conduct leakage current. And therefore the SCR is off. Then you have the mode 2 of the operation. So mode 2, we're talking about when the anode is more negative. When the anode is more negative with respect to when the anode is more negative with respect to cathode, the SCR is reverse biased. The SCR is reverse biased. The SCR is reverse biased. And junction J2 is forward biased. It's reverse biased. Junction J2 is forward biased. Junction J2 is forward biased. And therefore, the SCR is off. Then we talk of the operation of SCR. So for us, we are realizing that anytime you apply the voltage in all the situations, the SCR is reverse biased. Then how do you operate the SCR? The first statement you need to know that when the applied voltage, when the applied voltage is increased to a critical value. When the applied voltage is increased to a critical value, a breakover voltage, it's increased to a critical value, whatever that's as a breakover voltage. The SCR is turned on. The SCR is turned on. Full stop. And this is because the junctions J2 breaks down. J2 breaks down and allows conductivity from the anode to cathode, since J1 and J3 were forward biased. So that's operation on how you can operate the SCR. You can have another operation when connected in the reverse breakdown region. If the applied voltage is reverse biased, if the applied voltage is reverse biased across the terminals, i.e., the anode is connected to the negative terminal of the supply. Connected to the negative terminal of the supply. J1 and J3, J1 and J3 will be reverse biased, while J2 will be forward while J2 will be forward biased. And therefore, the SCR will be the off mode. And so the SCR will be off. So with these two conditions, the SCR will remain in an off state so long as the voltage applied is below the breakover voltage, and will only turn on when we apply a voltage that's greater than breakover voltage. Then sometimes you can be asked to draw the equivalent circuit of an SCR. So let us draw the equivalent circuit of an SCR. SCR equivalent circuit So we're going to draw the SCR equivalent circuit so that you understand how it operates. So this is the equivalent circuit of an SCR, and this circuit is also sometimes called the transistor analogy of the SCR. You can also express in using the transistor analogy of the SCR. And what happens is that when the collector of each transistor is connected to the base, when you look at this, the collector which now produces the IC1 is connected to the base, and the collector which produces the IC2 is connected to another base also. So the collector of both the transistors is connected to the base of the other. And for this case, we shall be able to have what we refer to as the current flow, so long as the gate here. So for us to turn this transistor off, so I'll turn off the SCR, we need to place a value below the conduction region, or below the required value for the transistor Q2 to conduct at the gate, so that the gate voltage is now reverse biased this to the cut off to turn the IC2 off, then the transistor Q1 will now turn off. So we have an action of the positive going. We have an action of the positive going feedback, because here it is going to have a current that is growing in nature. Let's talk of the positive action feedback or positive feedback, because the current keeps on increasing. So when we have this, then we need to understand on how this is able to operate and how this is able to operate. So one of the things we need to explain here is that the collector of each transistor, is connected to the base of the other transistor. They connect to the base of the other transistor. So the first statement, when we know that, when we now have that, when the voltage applied to the gate terminal is enough, transistor Q2 will turn on, and its collector current IC2 will saturate transistor Q1. Hence, the conduction will produce a positive going feedback, positive feedback that will retain the SCR in the conduction mode. In the conduction mode. If the base current of the transistor Q2 decreases, the base current of the transistor Q2 decreases, the collector IC2 current, the collector current IC2, the collector current IC2 will decrease. And if the decrease is much higher, transistor Q1 will go into cut off. Hence, turning off transistor Q2. And so the SCR is turned off. So from this analysis I've done today, we still have to understand on some of the ways of triggering the SCR that we have not discussed here. So in our next lesson, we shall be able to discuss ways of triggering the SCR and how we can have the VI characteristics of the SCR. So let us meet in our next lesson.